Hey everyone, so let's solve today's LeetCode POTD meeting rooms 3. So the problem states that we are given an integer n which denotes the number of rooms that we have indexed from 0 to n minus 1. Now we are also given this 2D integer array meetings where meetings of I will have a meeting from start I to this closed interval end I. Okay, and all the values of start I are given to be unique. Now these meetings are allocated to the rooms in this following manner. So each meeting will be taking place in the unused room with the lowest number. And if there are no available rooms, then means the meeting will be delayed until a room becomes free. So for example, if we have a single room only and a meeting is currently taking place at that means in this room, then for the new meetings, that room will be only means available when the previous meeting has already been completed. Okay, so delayed meeting should have the same duration as the original meeting, just that it will be starting at a later time. Okay, now when a room becomes unused, meetings that have an earlier original start time should be given the room. Okay, so as soon as a meeting is completed from a room, then we will means assign new meetings to that particular room, and the meeting that will be assigned should have the lowest start time. Okay, now we need to return the number of rooms that held the most meetings. So means we'll try to assign meetings in this manner to each rooms, and then we need to return the room which held the most number of meetings. And if there are multiple rooms which held the most number of meetings, we need to return the room with the lowest number. And I hope the meetings are in closed form. That means start to end of I means the meeting will be happening from start till end minus 1. Okay, start till end minus 1. So and number of rooms that we have can go up to 100, and the length of meetings can go up to 105. So let's see the given input. So we are given n equals to 2, so we only have 2 rooms. Okay, now the meetings is from 0 to 10. So if you have 2 rooms 0, so currently this will be having a meeting from 0 to 10. Okay, now at time 1 this meeting comes, so it will be having a meeting from 1 to 5. Okay, now we'll see this one room will become free at time 5, because at time 5 it becomes free. So we'll not be able to take any meetings in the time period, means time 2, time 3, time 4. Okay, so as soon as time 2 arrives, this meeting will not be assigned to any room, so this meeting will be deleted. As well as at time 3 this meeting will not be allocated to any room, because none of the rooms are free. Now at time 5 this room becomes free, so this will be modified with what we have a meeting of duration 5. Okay, so at 5 what you'll have, at 5 this meeting will be started. This meeting of 2 to 7 will be starting, and it will be starting for what duration? 5 duration, because the duration is 5 seconds, so it will be happening till 5 to 10. Okay, so for room 1 we will have these meetings. Now we see we have another meeting which has a start time of 3. So at time 10 this meeting will become over, this room will become over, as well as this room will become over, right? But we know we need to assign it to the earliest room which becomes available, because if there are multiple rooms available, it will be as unused room with the lowest number will be available. Okay, so in this manner we'll be assigning the room meeting with time interval 3 to 4 to this meeting with in the time interval 10 to 11. Okay, so we saw these two meetings were assigned to the room number 0, and these two meetings were assigned to the room number 1. Hence the number of meetings that each room held was 2. So since we need to return the number of rooms that held the most meetings, so since both of them held 2 meetings here, so we need to return the smallest room with the smallest number. So the smallest number simply is 0 here, and that's why the output here is simply 0. Okay, so this is the case of in how we'll be assigning rooms in this case. Let's see another input. So we are given 3 rooms here. Currently we have 3 rooms, 0, 1 and 2. So first meeting we have, it will be happening from 1 to 20. Second meeting will be happening from 2 to 10. And the third meeting will be happening from 3 to 5. Now at time 4 we see there exists no room which is free. Okay, no room is free, so we'll not be able to assign any values. But at time 5 this room becomes free. So since this room becomes 3 free, we'll be able to assign this for this duration. So for 4 to 9 we'll be able to assign this room, so it will be happening for the same duration from 5 to what? The duration here is 5. So we'll be assigning it till 10. Okay. Now this meeting who has a start time at 6 will not be able to assign it to any of the rooms because all the have all have at n times as 10. Now we see like this means both room 1 and both room 2 will become available at time 10. So we'll be simply assigning it to room 1 because it is earlier room number. So time it will be assigned for duration 2. So it will be assigned from 10 to 12. So we again saw like the meeting 1 held 2 rooms. Meeting 1 means we saw like the meeting 1 held 2 rooms. The meeting 2 held 2 rooms, 2 meetings, and the meeting room 0 held 1 meetings. So I hope this was the case in this case as well. Room 0 held 1 meetings while room 1 and 2 held 2 meetings. So hence we need to the maximum number of meetings were held in room 1, and that's why 1 is the output here. Okay, because we need to return the earliest room number with the maximum meeting. So since both 1 and 2 had same number of meetings, you will be returning 1 here. So what will be like the most naive way of solving it? So we saw like the number of rooms that we have can go up to 100. So what if for each room we try to find out the earliest time at which it can be assigned? Okay, means for each room we'll be trying to find out the earliest meeting that can be assigned from these meetings. Okay, and then simply increase the count of that room. So what we can do here in the brute force, the objective here is simple. We need to find the room index from 0 to n minus 1 that holds the maximum number of meetings. And if the multiple rooms have same number of maximum meetings, then we select the room with the smallest index r. And the rules are simple. A meeting must be assigned to the unused room with the lowest index. If no rooms are free at this particular start time, then the meeting is delayed until a room becomes free. And now the new start time of this meeting, delayed meeting, becomes a release time of the room. So as soon as the room becomes free, at that time it will be again starting, but the duration remains the same only. Okay, so if we had the duration from si to ndi, suppose it starts as this ti, so it will be going till ti plus di, where duration of I is simply end of I minus s of I. Okay, now and also we need to make sure that the meetings are processed based on their original start times. Okay, so that we process it in increasing order of start times. So try to first satisfy this condition. So this meeting should be processed in on the basis of original start times. So we need to simply sort the meetings on the basis of start times. That is the first step we'll do. We'll simply, the part one is sorting and pre-processing. So we need to simply sort the meetings on the basis of start time. So we can simply normally sort it, and it will be sorted on the basis of start time. Now the brute force approach will be to for each room, since the number of rooms is so small, we can simulate the process by iterating through all rooms for every meeting to find the best candidate. So for every meeting that we have, meeting can go up to 1e5. So for every meeting, we'll iterate through all the rooms, which can go up to 100 only, and find out the best room for this particular meeting. Okay, so how we'll do it? We need to maintain like the number, the time at which this room will become free. Okay, we need to store that information, as well as we also need to know like what is the number of meetings that had already held in that particular room, so that we are able to find the maximum count in that. So we'll need to maintain two values here. So let t be an array of size n, where tj represents the time at which room j becomes free. Okay, so we'll initialize all the rooms tjs as 0 initially, because all the rooms are initially free only. And we also create a cj vector which denotes the number of meetings which are held at each room. So we'll need to maintain these two arrays. One denotes the time at which this particular room becomes free, so that when we have a given meeting, we'll simply iterate through the rooms and find out the room which is available. Okay, and the second, we need to find out the number of meetings that have already occurred in each room, so we'll maintain a count vector as well. Now for each meeting mi equals to si and I, what do we want? We want to find out the first room which is available, and if no rooms are available, then that means we'll be delaying the meeting. So it will be starting at the time, we'll find out the minimum time at which any of the room becomes free, and then we'll start this current meeting at that particular time. Okay, so we'll be able to find the room on the basis of either the minimum time, or if the start time of this start time is greater than or equals to this t of j. That means the time at which room j becomes free. If the start of this meeting is greater than or equal to that, then simply assign this meeting to this room. Else, if none of the rooms satisfy this condition, that means we will be finding the minimum TJ. So that means the minimum time at which any room becomes free, and will start SI from this time. Okay, so I hope the logic is clear. It is simply a two-step algorithm. So we'll identify the candidate rooms. We search for a room that is free at or before the meeting starts. So we'll find out all those meetings. So we have means whose start time means the time at which it becomes free is less than equals to the start time of current meeting. Now there exist two cases. Either like means these some rooms are available. So if some rooms are available, we simply need to find out the minimum J. Okay, so we select the room with the lowest index from these candidates. So chosen room Y will be the minimum J which satisfies this condition. Okay, now how do we update it? So we know like if we have chosen this room R as J, so new ending time of this will become the EI, means since we have the meeting from SI to AI, so new ending time means the new time at which this rooms becomes free will be simply EI, and we have increased means used one meeting at this particular room, so we'll increase its count by one. Okay, now what is the case where no rooms are available, means no room satisfy this condition? So in that case, what we'll do, we'll find out the minimum time at which any room meeting exists. So since all rooms are busy, we must wait for the earliest room to free up. So we find out the minimum availability T min from this free array. Okay, now we select the room that finishes the earliest, because if there are and if there is time, we'll pick the installation index. So we find the room with the minimum time, and if they are multiple, then we'll find out the lowest index, and that will be the J with that we'll be choosing. Now how will this T of R updating in this case? So we know like the meeting will not be starting at current SI. It will be starting at what? It will be starting at T of R. Okay, so the meeting is delayed. It starts as this T minimum that we'll be getting, which is currently stored in TR. So we'll update our TR with initial TR that we had plus the duration of current meeting, which is from SI to NI. So the duration is simply NI minus SI, and we simply increase the count of R by 1. So this is the approach that we'll be following, and once we have the counts of each meeting, we'll simply find out the room which has the maximum count, and if there are multiple rooms with the maximum count, we'll find out the one with the lowest index. We can simply iterate through this count array and find out the maximum room with the maximum meeting. So I hope the entire algorithm of brute force is clear. What we try to do is, for each meeting we try to find out the minimum available room and means the minimum index of the room which is free. So both of the values we are able to find out, and means using simply iterating through the value. So the overall complexity of this approach would be of the order of n into m, and it will be a 1e7, which will get accepted in like limits of 1 second. So let's see the implementation for this approach, and then we'll be seeing whether some optimizations are possible or not. So we will simply sort the meetings array. Now we create this room, means the free time, the time at which each room becomes free, as well as the meeting count. Okay, now we iterate through the meetings, the current start as well as end. We find out the duration. Now we need to find out the best room. Okay, so we need to iterate through array, and we see like whether this condition is satisfied, means the free time of I is less than or equals to start. So that means this is the ith room that we will be choosing, so we will simply update it and break. Now if this best room remains -1 only, then it means that there was no room which satisfies this condition. Hence we need to find out the minimum available time at which means from the free array. So find out this minimum available from the free array. Okay, and then update our best room. So we'll be able to find out the room that we'll be using from these two steps. Either it will be like already, means it will be starting at SI only, or it will be starting at this best room of I, means based on the minimum availability time. Now based on this, we'll be able to find out the end time. So if the current start that we had was greater than or equals to this, the end time before, so it will be starting at start only. So they update the end, means the time of free of this will be simply end I. Okay, so or start of I plus duration, which is end I only, because SI plus duration is simply end I minus SI. So it will be SI only, means end I only. And if we have, means if it is starting at a minimum time, means this minimum available time, then it will be simply what? It will be simply the room availability of time of this plus duration. And in the end, we will simply update our both of these values with the new end time, and in the end we'll simply increase the meeting count. And once we have already, yes, this meeting count will be storing the number of meetings in each room. We'll be needing to find out the room with the maximum count. So we'll simply iterate to the maximum meetings and the result room. Now, if the current meeting count is greater than the maximum meeting that we have found so far, we'll update the max meetings as well as the room that we'll be using. And we'll simply return this result room. So this will be like the overall approach for this problem. This sorting will be taking a big of m log m, and this overall thing will be taking n into m, and which will be order of 1 and will get accepted. So I try to submit this code here and see how much time it takes to run. This is the same code that we discussed. For each meeting we try to find out the best room that we can get, and then means for doing that we simply follow whatever algorithm we need to do. So it gets accepted, it runs in 89 ms and beats around 36% of the solution. So like it is a pretty good approach. Now can we, like we see, like this m log m we cannot avoid. Okay, this iterating through the meetings we cannot avoid. Now what we are doing inside each step, we are finding the minimum available room. Okay, so either we are finding the minimum index of free room. This is what we are doing here, minimum index of free room. And if this minimum index does not exist, then what we are doing, we are finding out the minimum time of used rooms. Okay, out of all the rooms which are already used, we are finding out the minimum time from all of them. Okay, so we are finding these two values. So can we like find these two values without means iterating through the entire rooms? Can we like pre-compute use some data structure which gives us these two minimum values in like suppose log n time? Okay, then our overall approach will be of the order of m log n, and which will be like a better only. So can we do that? Means the problem that we have is to optimize these two tasks, finding out the smallest in room with smallest room index which is free, and if that does not exist, we need to find out the smallest means minimum time of the rooms that are already used. So let's see like how we'll be utilizing priority queues to find out these two minimum values by creating two priority queues on the basis of our requirements. Okay, so let's see the approach using priority queue, which will be of the order of n log n, because we are trying to optimize the big of n that we are using to log of n. So to optimize the means finding the lowest index free room and the earliest finishing room, okay, we can use two priority queues or min-heaps. Now how will we be using these two priority queues? So first room is to h free, which denotes the means which stores the indexes of the rooms that are currently free. So if we store all them in priority queue, the top will be simply storing the index of the free room. So we store indices of rooms that are currently free. Now the min-heap will be storing the smallest index at top. And what will be the initial configuration? Initial configuration will be all the rooms are free, so we'll push all these values in the priority queue. Okay, so h free means we'll be able to find this in like normal time. Now what do we want? We want to find out the room which has the earliest finishing time. So we want to find out the room as well as we need to find out the finishing time as well. Means first we need to sort it on the basis of earliest finishing time, and once we have the earliest finishing time, we need to identify which room belongs to that earliest finishing time, right? So we'll means create a priority queue of occupied rooms which will be storing the release time as well as the room index. Okay, so that it is sorted on the basis of means release time, and if the release time are equal, these room indexes are means the smallest room index appears first. Okay, so if release times are equal, order by smallest room index. So on the basis of that, we'll be able to find out the smallest time at which the this any of the rooms become free, and on the basis of that, we'll be able to identify the room as well, so that we are able to increase the count of that room for the next meeting as well. So now what we'll do, for each meeting of we'll iterate through the simple meetings array, and we'll need to find out both of these informations as we did. Now instead of order of n, we'll be doing it using priority. So we need to the first step is to, since we have reached this particular SI time, so in the used rooms array, whatever like means whatever rooms that have a previous ending, means since all the means in this HBZ we have all the release times. Okay, so all of those release times which are less than equals to this SI, we'll be moving those rooms from this busy to the free. Okay, So we'll identify all those release times which are less than equals to this current SI that we have, and we'll identify the room indexes and move this room indexes from H busy to H free. Okay, so the first step is that because we have reached this point of time, so we need to identify whether we are starting at this SI only or we'll be starting at some low means later time. So first step is to release the rooms, move any rooms that we have finished their meetings previous meetings by time SI from H busy to H free. Now once we have done that, means H free will be having some values and H busy will be having some values. Now there might be the case that H free has some values or H free does not have some values. So if H free has some values, that means we'll simply miss the smallest free room already exists. So we'll be starting at SI only. Okay, because a smallest free room already exists. So we'll see like if rooms are available, that means H free contains a value, so H free is non-empty. So we'll get the room with the smallest index, which is simply like H free dot top, and we'll schedule the end meeting. So end meeting should be simply ndi. So we'll push the busy for R with this value, and now we increase the count of R by 1. Okay, so this is a simple case which we means initially find out the initial means for the first room which was empty. Now if rooms are not available, that means H free is not empty, then we need to find out the room with the minimum finish time. So we'll be doing that. Since no rooms are available, that means H free is empty. Okay, so we have wait for the next room to free up. So we'll find out the means the smallest room that we have which will getting means executed first, completed first. It will be stored in HBC. So it will be simply hbc.top. The time finish will be able to get as well as the room corresponding to that. Now we will schedule the end time as it will be starting at T finish, and it will be happening for a duration which is simply ndi minus si. Okay, so this will be, so for R we'll be pushing this means removing this and pushing this in this. Okay, and we'll increasing the count of R by 1. So this is the same approach that we'll be using. Instead of big of n, we means identify that there are two values that we need to find out in means which are means minimum values that we need to find, and we saw like we can use simple two priority queues because both of the values we need to find out the minimum, so we can use two min heaps. On the basis of that, we try to store the relevant informations in the priority queue, and simply we are able to update these counts. And once we update the counts for all the meetings, after that we simply find out from this count the maximum means the room with the maximum number of meetings. So I hope you were able to see like how we try to optimize the order of n that we are using inside for each meeting to order of log n. Okay, means it is like the number of meetings that we'll be having is order of n, and yeah, so it will be overall order of log n only. Okay, the maximum size of priority queue can be n only. So let's see the implementation for this approach and see how we have like optimized. Most of the part will remain the same, only these two parts are getting changed, so we'll be finding it in like a login time, and everything else will remain the same. So let's see the approach. So we'll create two priority queues, two main heaps. First is the free room, and second is the pair which denotes like this is the ending time as well as this is the room at which that ending time is happening. Now initially all the rooms are free, so we simply push it in free rooms. We initialize this count. Now we iterate through each meeting. We find out the current duration. We'll remove all those meetings from busy rooms whose like release time is less than equals to start. Okay, so while this busy room is means not empty, as well as the ending means the release time is less than equals to start, we'll move this means the corresponding room which is stored at second to the free rooms, and we remove it from busy rooms. Okay, and now we'll see like if free rooms is not empty, that means there already exists some free rooms, so we'll be starting si as si only, and we will be moving till means the end time will be simply ndi. So we'll be pushing busy rooms as end and this room, and we'll increasing the count of room by 1. And if this free rooms is empty, that means we'll need to find out means delay this particular meeting. So we'll find out the earliest room as well as the earliest finish time, and the new meeting will be happening at finish time plus duration in this room, and we'll simply increase the count of this. And now once we have done that, means we have simply optimized the algorithm that we are using, and once we have done that, we'll simply find out the maximum meetings and the best room that we'll get. So if the count is greater than max meet, we will update the max meet as well as the best room that we're having, and simply return the best room. So this will be overall, we see like this is going till big of m, and each operation that we are doing inside this means popping will overall it will be means the number of poppings that we will be doing is order of n, and means order of m, sorry, overall, because means for each meeting some meeting will be pushed in room, so overall it will be means this will be happening overall m times. Okay, and the popping and everything, since the size of priority queue can maximum reach to size n, so it will be big of log. So overall complexity would be big of m plus n log n. Okay, and we have initially sorted it, so m log m as well. So this is the overall time complexity of this approach, as well as the space that we have used is also order of n. So I hope you were able to follow along with the approaches discussed, how we try to means get rid of this extra big of n that we had to identify that we need to find out some minimum. So let's try to use some data structure. And from that we saw like we can use priority queues here. So let's try to submit that code here. This is the same code that we discussed using two priority queues. Let's try to submit it. Initially it ran in 89 ms. Now it should run like faster, I think. Let's see how much time it takes to run. It is running. So I hope like you got the intuition of how do we like approach these kind of problems. First was the means thinking about this brute force was important here, and once we like know how this brute force will be happening, then we are able to solve the problem. Okay, so means in this case writing the brute force and thinking about brute force was important, because that was like pretty important, which helped us move towards the most optimal solution, and runs in 67 ms, and like this is like the one of the most optimal approaches. So I hope you were able to follow along with the approaches discussed, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining in any of the parts, then make sure to comment down. I will be happy to respond. Thank you so much for watching.